and then I'll hand over to Abdul. We've got a few more coming through.
Good morning, everybody.
Good morning.
Good morning.
Yeah, happy to be here once again. Today, we're gonna start from where we stopped yesterday. And I want to ask if we have been able to install Visual Studio Code on our system. Have we been able to install Visual Studio Code?
Yes.
Oh, that is great.
Yes, we started.
Okay. That's great. So, but before we continue with the Visual Studio Code, we have to just go through our slide. I'm sure everyone, we can see my slide there, right?
Yeah, we can see it.
Yes.
Yeah, good. However, we jump some of our studies like the class and functions. So we are still going to look into them with time, but let's continue with what we are supposed to do today. So now we talked about data science libraries. These are the common libraries we're going to be talking about in data science as an analyst or a data scientist. You will be dealing with this kind of libraries like NumPy, Pandas, Matplotlib, and Seaborn. There are others like SciPy and etc. Beautiful Soup. We have different libraries that you will get exposed to as we go on this journey. But these are the critical libraries we are supposed to get used to. The NumPy, the Pandas. The NumPy is just like we've been talking about list, and by now I believe we understand list very much. So we have another type of data structure that look like list, which is a NumPy NP array. It's just like a list. Difference is just that when you are working with list and working with NP array at the same time, the memory occupied by NP is smaller compared to the memory that will be occupied by list. So, and then the computation speed in NumPy is faster compared to the list. That is why, and you know, as a analyst or a data scientist, you will be dealing with a lot of data. And these data can be in thousands, you have millions and entries, and you want it to be very fast. You want to do computation very fast. So you cannot be working with a list. You work with NP array. And at the same time, the memory reserved used by NP array is smaller compared to when working with list. So you're going to be dealing with NP array majorly. And when it comes to Pandas, you know, when we are dealing with list is just an array like a single line. Like when you talk about students, let me see, then I'm coming on. Okay, let me open another Google Colab for today's lecture. a condition where we have a list. For example, you have my list, and it's just going to be like this, and sometimes you don't even know what each element represents. So you are working in a list that look like this. You can see it's just a single array. It's just a single one like this. And now we want to talk about a tabular data, something that will look like a data we are used to, something that we have a row and column that will look presentable. Then we are going to be using another data structure that is stored that will be stored in Pandas. So we use Pandas for a data structure of things that look like table, like the kind of structure we have in our Excel. So when you have an Excel, you have rows, you have columns, and like that. So when you want to deal with such data or data, you use Pandas. At the same time, when after you have your table, you also want to visualize them. You want to look at them like you want to present your findings in a graph, in a chart. Then you use another libraries like a Matplotlib, and you also use if sometimes you use Seaborn. What you do in Matplotlib, you also do it in Seaborn, and there are other libraries, but these are the one I use majorly. So you present your findings, your data, you present them in the chart using either Matplotlib or you use Seaborn. So let's look into what before we talked about these data we are talking about, what are the sources of data? Please, let's unmute ourselves and quickly talk about these sources of data that we can always talk about. Please, what are the sources of data? Like, for example, I'm looking for a data. Where am I going to get them? Do you have an idea?
Can be from a website.
Okay, website like, please, can you elaborate on that?
Let's say like Wikipedia.
Wikipedia. Okay, okay. And sometimes it can even be like you want to get a data for a particular company like British Airline or Airways. You want to get their data, you just move to their website and get the data from there. Some of this data can be in tabular form, and some can be in a text, like review of for example, some people I work on a data. Maybe I should just share the data with you. I work on a data that was talking about British airline and how people feel when they board. So they at the end give their review like the flight was this, was that, is going. So you can get a data that will not be a tabular data like that. That will just be a text. So you can get it. You can get some that will be a tabular data. So which other source apart from the website? Where did you think we can get data?
Side links.
Where?
Side links.
Site links?
Side links, yes.
Okay. I don't really know much about that. Which one is site links?
For example, when you post like a blog, and you know, people go through the blog and you collect data through the side links through the
okay. I got the like you have a form, right? You design a form and you are using it to get the data from the users of a particular what do you call it? A particular site. And at the same time, you know, I can set a Google form and ask questions like questionnaires. Okay, you can also get some data through questionnaires. Now, there are some of these data that are stored in repositories. I'm sure we know some of these repositories. Hello, everyone. Hello.
Like cargo.
Yeah. Yeah, you have repository like cargoes, you have like UCI. So those are the kind of data we'll be dealing with. So let's look into how some of these data on these repositories look like. For example, if I go to Kaggle, somebody just mentioned Kaggle. So this is Kaggle. Just log into this kaggle.com/dataset. So you're gonna see that there will be a lot of data there. So if you go to the Kaggle website, you can see that we have a lot of data, and you can search the kind of data you are looking for. You know, as for me, because of my background, I love to always look for data in Earthline, like art failure prediction. You see, this is a data here, and this data is in CSV. You can see book sales, cyber, something like that, and you can just go and search for different data on Kaggle. So we have different data sets on Kaggle. At the end, we are going to download one of these data sets and try to do one or two works on them. So let me look for diabetics data set, for example. So we have diabetic data set. In this data set, like this one now, you have about 1,011 data sets here. So if I want to use this data set, I can click on it, look at the description of what I have. So the data set, you can read it like at least 21 years old of Pema India heritage. You can read about the data set. The data set is originally from the National Institute of Diabetics and etc. You can read it, know what the data set is all about. And when you go, you can know more details about the data set. In the data set has 9 columns. 9 columns. And the columns include something like information about pregnancy, glucose level, blood pressure, skin thickness, insulin level, BMI, and the diabetes pedigree functions. And so this is how the data look like. You can download this data and then explore. And at the end, the data is telling us about people that have diabetics, like the number of people that have diabetics, and some people have diabetics based on these parameters. So those are the kind of data we'll be dealing with. But now, you see, this data is in form of CSV file. You can see this is CSV. It's a CSV file. So when you download this, it's going to be in form of CSV that you will need to import into your using Pandas. You can import this using Pandas. So there could be some data in form of Excel. So we are used to Excel data set. Everybody knows about Excel. So your data can be in form of Excel. So you can import in form of Excel. We have some that are in Json. So majorly you'll be dealing with CSV and Excel file. Another type of repository apart from Kaggle where you can get data is something like UCI. This is a UCI. UCI is just this UCI. When you go to this UCI, you are going to get different type of data. It's very similar to that what we have in Kaggle. So you can see if you want to know heart disease, this is heart disease, and then when you click on it, you see different type of features that have been collected. So you see in this heart disease, we have the variables, the columns, they are age, the cell, the CP, the trace, P, BP, COL. You are going to be told what all these things represent, like this one, like cholesterol. You are going to be told what all this abbreviation means. So sometimes you may not understand if you are not in that field. If you are not in the field, you may not understand what they mean. Everybody understands what age means now. We understand what the cells means. But when it comes to CP, we may not understand what we mean by the CP, like the cholesterol level, we may not understand what it means. So it depends on your field. The data you look for, they may depend on the field you are working in. For example, if you are a counselor, I saw a data some times ago, like if I were to be a counselor, I can search for a data on marriage. Maybe, so if my marriage is not correct, no problem. I should find. Let me search for a data on marriage. I saw the data was like, if you are a counselor, for example, there are some things you can look into in marriage to counsel some people based on existing data, like if the marriage is going to be a successful one or not, or things like that. So you can go into such data. And if you are working in sales, maybe you look for sales and data and etc. So you can find most of this data on Kaggle and on UC High. Now, once you get the data, what is important is that you know the formats which the data you have the data. Some of the major data you'll be working with, I already told you, is going to be a CSV file or it's going to be an Excel file. So when you get this data, what are you going to do with it? That is not the question. When you get the data, what are you going to do with it? Well, once you get the data, you bring it to your Google Colab, or you bring it to your Jupyter notebook. When you bring the data to your Jupyter notebook, you can bring it using the library we have discussed earlier. And some of this library, before you can use them, you have to install them. The other time I was talking about pip install. You can also install it here. Pip install NumPy. This is how you are going to run it. You install NumPy, pip install NumPy. So when you click it, it's going to be installed on your system. So already exists because we are using Google Colab. Google Colab may have a pre-installed NumPy. So you can install pip install pandas, install pandas. I told you those are what we have to install. You install pandas. So other things we have to install, let me check. We said we have to install the Matplotlib. We also have to install Seaborn. So again, you come again and say pip install, because now you want to be working with data. So you install Matplotlib, you install that, you install pandas. What happened? Pip install, okay, the install is not correct. Install, Matplotlib. You know, I copied it. You know, I told you once to copy it, most of the time, you're always going to get error. So because I copied it, so it copied some code along with it that you cannot see. So I've installed Matplotlib. Then you also install Seaborn, pip install Seaborn. So you install it. You install the Seaborn. Before you start anything, you have to install all these things so that when you are calling the libraries will already be available on your notebook. You can install what is called Beautiful Soup. Pip install Beautiful Soup. pip install, and so many other things. But there's one that is still very important that we have to install. Is I think I write it here. Yeah, you install this openpyxl. SL. If you don't install this one, you will not be able to import any document that have to do with Excel. Pip install openpyxl. If you don't install this, you will have problem importing Excel. So when you install that, now you can continue. You can now begin to, what happened? No machine distribution found for openpy. Okay, L, there is L at the back. Let's see. Okay, installed. So you have to install everything. So after you have installed, these are the major one. You install NumPy, you install Pandas, you install Matplotlib, you install Seaborn, then you install openpyxl. Now you can now begin to talk about where is our data? What can we do with this data? How can we do wrangling on them? So now the major thing we have to do now is to look for a particular data set. But before we look for a particular data set, let's try to curate a data set ourselves. Can we curate a data set by ourselves and make it to become something like a data frame? So we used a data yesterday for people that were around. This is the kind of data we used yesterday. Let me put it in this new Jupyter notebook. If we have this data, for example, we have a student's name, we have what do you call it, math score for them, we have the chemistry score, we have the biology score. We can begin to change out this name to what we have here or whatsoever. David, Aisha, Bola, Philemon, Anthony, Ahmed, Lillian, Tel, and UBA, Bar, like that. Those are the names we have. Now, these are their corresponding scores. But you see, this is not interesting at all. You have to be looking at David. When you check David, you see what is David's score. You go and check 76 in math, you check down. This would have been better presented in data frame. So another thing we did yesterday was that we tried to find average yesterday. We find average for this course. But for today, let's just try to see how we can make this thing to become a data frame. One of the way to create a data frame is to use create a data frame through list or dictionary. So we can create a data frame through list or dictionary. Another thing we can do, apart from we import a data that is already structured in a tabular form, we can make our own tabular data structure. So how do we make this? So we want to make this one to become a dictionary. How can we make this to become a dictionary? One of the things we can do is to use each's name as a key. So let's use the name as key. It means the key for we can say David. When we say David, we now go and put the score in front of the David and put something like okay, the scores are already there. We have the math score. Okay, we can use all these things as the key for our dictionary. For example, if I have a dictionary, let me just set my student dictionary. Student dictionary. If I set a student dictionary like this, is equals to, let me use the curly bracket to denote my dictionary. So I will now set this as a key. The first thing I have here is the name of the students. So if this is the name of the student, I set it like this. I now say is equals to the dictionary. Is equals to the value. If this is the value of the name of the student, just copy it and paste. So, comma. Then I can do that for everything. I have I also have this. Something is already wrong, but who want to correct me? Something is already wrong with the dictionary I'm doing. Please, who want to correct me with that? We are going to have an error. So I want someone to quickly tell me what the error will be. Anyone? You can see that the name of the student here is a string, and I'm not putting that. So if at the end, we are going to have a problem. So you can see this is a string, and I'm not putting that as well. So this is also a string. And at the same time, I'm not supposed to use equals to, since it's a dictionary. And this as well is a string. So if I change this from being, I put this, and I put this. Now we have a dictionary. This is a dictionary. I turn the name of the student, I turn it to a key. So immediately you go under the name of student, you are going to see all these names. Immediately you go under this key, you are going to see the score in mathematics corresponding to each name. So if I run it, I now have a dictionary. I can make this dictionary to become a data frame. So if I want to make it a data frame, there is what we call a data frame. You can call it like student data frame. Most time we use the head data frame to be equals to pandas PD. Okay, we import pandas. Have we imported the pandas? No. Before we can use any of this library, we have to import them first. We only install them. We are yet to import them. So let me import them first. If I don't import, there is no way I can use them. Import pandas as the as PD. That is the conventional. You import pandas at PD, panda. If you just import without saying as PD, it's still gonna work. But every time you have to use the word pandas, and because it's long, we just sort it to what as PD, so that anywhere we are supposed to use pandas, we'll be using PD. We import NumPy in case we want to use NumPy. Import NumPy as NP NumPy, and at the same time you import Matplotlib as Matplotlib. So you can import it as anything, but since we are not going to talk about Seaborn and etc. for now, let's just stop on this. So if I run it, it means the library, apart from installing it, I've imported them. Now I can use them. Now, since I've imported them, I can now come and define a data frame. I say, if I have a variable name, student data frame is equals to PD. You can see because I use PD. If not, I will have written pandas. PD dot data frame in capital D, capital F dot data frame. What did I want to set as data frame? The dictionary I had. This is the dictionary. If I put the dictionary inside this place, the dictionary will automatically turn to a data frame. So if I run it, so it has run. So now I now have a dictionary. This dictionary has now turned to a data frame. So now I can access this data frame using print data frame, or I just copy it and paste directly. You see, I can say print data frame and print student data frame, or I just paste it directly and run. You will see the data frame. You can see now that this is more beautiful compared to what we have as a dictionary. You see, it's now telling us that David, this is student's name, David, mathematics score is this, chemistry score is this, and biology score is this. Then Aisha, this is this is that, this is this. And this is how to build data. You can see the data came from the list we were used to. Everybody understand how we can get a list. We have a list, but working on the list is not going to be so powerful or interesting to us. We like, okay, let's turn it to a dictionary where each variable name becomes the key in a dictionary. So after that, we now use it as a data frame. You can see this is more presentable as a data frame. However, we may not necessarily have to use this as a dictionary before we can turn it to a data frame. So let me just copy code and we run instead of let me just copy the code and run. So another way that we can do that is we have done that of the dictionary. Let me just copy this and let's run that. Interesting. So what we did here was that we converted the data frame and we converted the list into a dictionary and we use it directly. But another thing we can do, instead of converting it to a dictionary, we could have worked with the list directly. If I have the list, these are the name of the list. I declare an empty data frame. This is an empty data frame. For example, oh, sorry. This is an empty data frame. I say data table. That is what I have as a data table, nothing in it. If I run it, it's just going to be ordinary data. Nothing is going to be in it. So yeah, if I like, I can now say, okay, if I have this data table, what did I have in it? This is the data table. If I run it, nothing. There is no table. You can see it's just like a calculator telling us that there is nothing inside this data table. Now, I now want to say, okay, this data table append the way we use like append. Let's append something in it. So this is what I want to append in it now. I want to append for the first one. I want to say, okay, I want to put some, I want to put a column that the column name should be student name. And that student name should be something student name we have initially. This is the student name. So I want this student name to be appended inside this empty data table, and I will have it as student name. But this is the way I want it this time around. I want it as student name. You can see here, we have student name because that is how we denoted the student name in our dictionary as a key. If we have written it correctly, just like what I have here as student name, then it's going to appear that way. But if I still want this, if I still want it to appear the same way, then I can just clean this one up. Oh, sorry. I can just clean this one up and say, no, I don't want it standard this way. I want it like this, student's name. So I will say to this data, empty data table, put something that is called student name and let it be the value that you take from this student's name that we have declared before. So if I run this now, the data table is not going to be the same thing. It's going to have one table. It's going to have one row. or a column rather, is going to have one column. You can see it has student table. In the same way, I can append everything just like that, and I will have everything all the same way we have it when we use a dictionary. So if I want to append everything, I can as well just run this. But if I run this now, the student name will appear twice. The one I just run, this one will be there, and at the same time, the another one that is student name that now has a name separated will also be there. Let me run. You will see that everything will be appended. So if I call on the data table again, and I run, you see, this one appeared twice because I run this one earlier. I did not remove it. So I'm also having it again as a student table, student name. So you can say it's the same thing. So what we are trying to say now is that apart from getting data from a questionnaire, you set a form as a questionnaire to get data in form of CSV, or you get it in form of Excel, or you go to a repository. There are other ways you can define your own data by yourself. You can even get data from a database using SQL to pull the data from the database. But you can also declare, you can also get your own, declare your own data frame using a list. When you get the data in a list, you can now, if you like, you can use it directly as a list, or if you like, you can convert it to a dictionary. When you convert it to a dictionary, you can now import whatsoever you are supposed to import, and from there, you get the data frame. This is the kind of data we are going to be working with. So it's not a data frame. It's not very clear. This one is easier because it is just like about 10 data row. We have 10 rows here. These are the rows, while these are the columns. We have how many columns? 1, 2, 3, 4. 4 columns. So these are the kind of things we are going to be dealing with when we are dealing with a data frame. Now, let's try to import a data from an external source. I have a data here. What you are going to do, okay, maybe let me see how I can attach a data to share a data with everyone. I have a data on my system. Let me go to chat. Let me get the data from the system and share the data with us. I have a data. Let me check. I have lots of data here. Let me check. Yeah, I have a data here. This one called attrition. Okay, I think I can see 2 data now. I shared 2 data. I think this data, they are in a Z form shared. So you download those data on your system. Let me try and get another data that I think I can share with us. I hope you can get the data. Let me share another one. Hello, everyone. Are you there with me?
Yes.
Have you downloaded the data? Okay, I can't get anyone for now. So let's go with what we have. So if I have this data, I have the attrition SL.
Sorry, Abdul, which data?
They are in the chat. I put it in the chat.
Oh.
Insurance data and at the same time attrition data. You can find them.
Yeah, I joined the chat group late, so I literally joined the chat group this morning.
Okay.
Is there any way you can?
Sorry, the Zoom chat, not the WhatsApp, not the WhatsApp
Oh,
group.
Zoom.
So it's, yeah, the Zoom one.
Yeah.
Thank
okay.
you.
So can you find the data now? Let me try to download one more data so that we can really understand what we're talking about here. Let me download the diabetic data and share with us. However, before you can download any data on Kaggle or you say hi, you have to register with your email. So when you register with your email, you will be able to download whatever data you want to deal with. So I will share another data with us. I'm downloading the data. So when the data downloaded, I will share it with us again. I'm trying to, so that we can see the two format of the CSV is like the two. We have the Excel format. We also, I want us to have the CSV format. Okay. I will share this data with us now. My system, download. So can you get the data?
Sorry, Abdul, are you sharing your screen? We can see but the cargo screen. So you're sharing.
Yeah, it's good. That is where I'm downloading the data from.
Yep.
So have you seen the data that I shared? You
Yes,
can as well download the data yourself. So if you have downloaded it, then we can continue because we can't do anything after except you download the data.
Sorry, Abdul, can I
Yeah?
can you insert those links again into the chat? Sorry,
Okay.
Zach.
The chart, I've shared the data in the chart. So
Yeah.
what did you need in the chart?
So I've joined on another PC, so I can't see.
Okay. I will share it again.
Thank you.
Yeah. Okay, I've shared another one. I've shared it again. Is that good, Barrios? Have we seen all the data?
Thanks, Abdul. All good.
Okay. So let me go back to my screen. Now, if I have the data I want to deal with, the first thing that we have to know is what is the nature of the data. Is the data in form of CLP? Is it the data? Is it in form of Excel? So you will now come to this side. You can see this side, since we are using Google Colab for now. So if you come to this side, you have to, you can see what I click. You see this folder. So if you click on this folder, so you now have to import the data from where it is stored on your system. Now, since it is stored on, okay, I want to deal with attrition data. So if I click on attrition data, I import it to the Google Colab. So you will see it's loading, and I will have it here. Okay, you can see here, I now have attrition data in form of an Excel. This is an Excel file. So since it's an Excel file, I will import the Excel file into the data frame. So how to do that? You read pandas.pd.read Excel. So let me just tell us what to do. So you all have your data with you, right? So once you have it, anything you want to call it, let me call it attrition data. Maybe I should call it attrition df. Data set is equals to pd dot, since it's an Excel file, this is an Excel file, this is the format for Excel file, dot read Excel. This is read Excel. So when you are reading Excel, what are you reading? I'm reading this name. You can copy the name. Let me look for a way of copying the name. Or just say copy path. So I've copied the name. So now, you know, I have to put it in, yeah. So now that I copied the name, I can run it. So it's going to import, it means the data has been imported. Now the data is now stored as this, attrition data frame. So this, you are less concerned about whatever you have here now. So this is the only thing you will be working with. So now if I want to see this, I can just put it here and run. When I run, the data will be right here in my system. Okay. Now, you know, this is the data. The data is for company S, which is trying to control attrition. There are two sets of this data. Okay. So it means this kind of data, we have three different sheets in it. The first one is the introduction. The second one is the main data. The third one is another data. So these are the descriptions on the data. We can specify the page we want to open. So I don't know what it's used to store the page. Maybe some of them may be stored as let me check, I don't know. If you open it, you are going to see what it is used to store the page. But since I'm not opening it, maybe I should just import another one. Let me get another data. Sorry. There are two data we imported. the first data is on attrition, is an Excel file. But this one are now it has when you check the Excel file can be multiple. You can have multiple files in it. So this one is having multiple files in it, and it is this place we are going to specify the one you are actually looking for. Maybe the one on the sheet 1, the sheet 2, the sheet 3, or whatever the name has been called. I don't know the name that has been used, except I go and open it on Excel and check the name that has been used. But since I don't know, and I don't want to go through that, let me just open the second file. So it's still the same thing. They are both Excel files, just the name that I will change. So let me copy the name from here. Let me just copy the name. The name, this is the name. So later, if I check what's the name on this attrition, we are going to open that again. So if I run this, but all these are just for demonstration purpose, and I run this, you are going to see that, okay, this is the file I have for this. So in this file, we have age, cells, BMI, children, smoker, region, and charges. So this is on insurance. The insurance, maybe this is about life insurance. So if this is about the life insurance, we are saying, okay, if we want to use this data to know what will be the charges for a particular, you want to check my charges now, what that is going to be if I am to subscribe to this insurance company. So like, okay, you are going to check what is my age. You are going to check this and say, okay, if my age falls here, for example, and this is what I have, and you check my body mass index, you check the number of children I have, and you check whether I smoke or not, you check the region where I'm coming from, then you will be able to say, this is what I will be charged. So we want to know the number of, there are so many things we can know from this data, but first thing we know now is that we can now import data from external source into our Jupyter notebook. The first data we have imported now is the Excel file, but at the same time we can import another file that is not Excel. Let's import another one like CSV file. So let me go and open the CSV file so that we can know how CSV file also look like. Please, I'm trying to get the Excel file so that we can know how that one also look like. So now that we have an Excel file, we have CSV file, we can also try to import CSV file. We have imported Excel file. This is the Excel file, how we imported the Excel file. We can also import CSV file if it is not an Excel. What we have to do here, we have to bring the CSV file. Hello, I'm with you. We have to bring the CSV file up. This is the CSV file. It's inside this I just need the file. I don't need the archive file. I have to zip it and so Control C. Let me remove it from the first. Okay.
Whenever you finish in the kitchen, you wipe every nowhere and see any. Now, no, you must wipe it, must.
Diabetics. Okay, the diabetics file is what I want to bring up. Now you can see if you check this place, you can see diabetics file .csv is different from SLSL. This one is SL. Why this one is CSV? If I want to bring this diabetics file up, I will just come here again and say, maybe I want to call it diabetics data. Anyhow I want to call it. Maybe diabetic data is equals to PD dot data frame. Oh, dot read, sorry, read SL. Now we are not reading SL, we are reading CLP. Yeah, does read CLP. So what is the name? So you can just type the name if you, but you can copy it. You copy the path, and you clear the remaining aspect, and then this is the name of the file. Then you put it in quotes. So we have imported this, then you run. It's still going to give us, oh, what is the problem?
You imported the wrong file. I think you imported Excel instead of CSV, the diabetes.
No, it's this CLV. Let me put R here and see, and rerun. Oh. Okay.
Check the extension.
Okay, it's diabetics.
.xlsx.
Sorry. It's diabetics file. I get what you are saying. I imported another file instead. So thank you. So is diabetics file. Let me just copy. I don't want to write. Sometimes when you have that, you can just put R at the back. It's going to help you out. You have some reason to put the R. Okay. Okay, now if I run it, this will be running the diabetic file. So you can call it any name you like. This one has run. So let me see, let me print it out. Print the diabetics file. You can print it by just putting the name as well. This is the name I decided to call it. And if I run it, it should give me, you can see, it's giving me in a table, telling me that this is the table I have for the diabetics. And it has 768 rows and 8 and 9 columns. This is it. But the way it is now, you may not like it, but instead of that, just copy it and put it down. Just write diabetics straight instead of putting print, so that it will display properly the way you want it. So let me just put it and run. Okay, this is it. I think this looks better. So this is telling us that we have 768 rows and 9 columns. So if you actually check, you are going to get 9 columns like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. The rows is 768. This is it. This at the row. So what we normally be done is that you will be shown the first 4, the first 5, and the last 5. If you want to see like the first 10, there are things you can do. So, but before we go into what we can do, let's quickly recap what we have done so far. Now, so far, we know that before you can work with any data, 1, you must install Pandas. And you must also install NumPy. At the same time, you can install some other libraries, but these are the major ones for now. If it's going to involve something like Excel, you install openpy libraries as well. So that is the first thing you do. After you install them, the next thing you do is to import them. Import those libraries. You install the libraries using pip install, and then you import the libraries using imports. So you import, and after importing, during importation, you can use some as alias to join your importation, like import pandas as PD. That is what is the conventional. But if you choose to use something else, no problem. But that is the conventional. Import pandas as PD. Import NumPy as NP. So you can use that. After importing, the next thing you have to do is to bring up your, of course, you have your data. Is either you have the data from a repository or through a questionnaire somewhere stored in an Excel or stored in as a CSV file. So those are possible things you can add, or you want to curate your own file, either through using what do you call it? List or dictionary. You can curate your own file as a dictionary or as a list. Another thing you may have to do, if you created your own file, another thing you can do is after that, after you have imported them, then the next thing is to look into how the data looks like. Like you have the data now in a data frame, and it's looked perfectly well. Then you can now look into the properties of the data. There are so many things you can do to look into the properties of the data. Imagine we want to work with this data. That is 768 rows. This is still even a small data. There are some data sets that will be thousands of rows. We have thousands of rows in them. So you now want to work with them, and you see, you can't see them. You only see like 10 of the data of the rows. Every other one will be hidden. There are so many things you can see. This just telling us that so many things have been hidden for us here. You can't see them. So if you actually want to see them, there are so many things you can do to see them. Now, after you have imported and you have installed, you have imported, and then you have brought up your data, as the case may be, the next thing you can do is to begin to explore, to check what you have on the data. So some of the things you can do on the data is to check you can check the first 5 rows, the first 10 rows by using add. So we have add, what you can do. So there are things you can do using head. There are things you can do using tail. When you use tail, you are checking the last part. Tail. There are things you can do with tail. There are things you can do with info. There are things checking the information about the data. So there are so many things you can now begin to do. But the most important thing now is for you to be able to import a data into your Jupyter notebook, which I believe by now, everybody should be able to import data to Jupyter notebook, either through using a CSV file or using an Excel file. There are things we are yet to do with an Excel file. Yeah, we are yet to do some things with an Excel file. Maybe I should quickly go through it. Let me bring up one of my Google Colab so that you see what I was talking about. Okay, I can't find the data I was looking for, so it's not here. So let me go and import it as well. Upload. Please, are you seeing my screen? Hello, everyone.
Yes,
Yes, I can.
Yeah.
Yes.
This is the data we're trying to look into. And when we were trying to look into we're trying to look into this data that we call the Excel data, the attrition, right? So, you know, I told you if I don't know what had been used to name the attrition, there is no way I can open it. This is the name that was used to store the attrition, this thing we are looking for, employees who have left. That is the name that was used to. So if I copy this and I put it back to the Google Colab we were using before, I should be able to import it now. So this was what we were trying to import initially. We were trying to import this one, this attrition problem. But we can't import it because there is a particular name that was hidden and we don't know. So df attrition now, let's just call it attrit, is equals to pd dot and Excel, read Excel, read Excel, read Excel. Sometimes those things are already there, so you just read Excel. So what Excel name do we want to read? Attrition. Let me put it, attrition. Attrition dot SLSS, comma, Control V. Now, if I run this now, this should run. Okay, you can see now I've been able to run it. So if I call this the same data we were looking for, we should be able to get the data. Okay, you can see the data. Now, you may not understand what I mean here. If you know Excel file, if you open any Excel, let me share. Can you see the Excel screen? In the Excel screen I'm trying to share? Hello, can you all see this now? Hello?
Yes.
Aha. Now, the problem we have in that data was because the Excel file we have, this Excel file we have here, has multiple file in it. You can see here, this one is only having diabetics, right? You can see diabetics here. Can you see that? Hello?
Yes.
Now, if I want to make multiple one and I keep opening more here, okay, I can edit this file. Let me see. I can edit it. Okay, now I think I can. I don't know if I can edit. Oh, this file cannot be edited.
It's read only.
Assuming is, yeah, it's on read only. Assuming is something I can edit. By the time I keep clicking this, it's going to open multiple files in the same Excel file. Now, if I now open this file, you can see it's read only. If I now open this Excel file, diabetics, I open it. It won't be able to specify the one I'm talking about. It will automatically bring up the false data. And if I have multiple data here, there is no way I can reference them except I know the name that have been used for other multiple data. That was what happened in this one, that we have to know the name that has been used. And the name that has been used was what I was able to get that help us to be able to get the data up. So that is what happened with Excel. Anytime you are dealing with Excel, if it is a multiple file, you still have an aspect where you have to know the name that is specified for the Excel. So that is the, and the name that was specified for that is employees who are left. If we don't put this, we will never be able to get that. It's going to give us the fourth one. Let me remove it again. If I don't put it and I run it again now, you see, it's going to run, but it's going to give me the first thing on the list. And this is the fourth file on the list, which I don't know the name. That is the first file on the list. But I don't want I don't want the first file. I want a particular file. You have to specify the particular file you want. And that was what happened here. So I specified the particular file, and now that I've specified the particular file, it's going to bring out that particular file. So this is the file. This is the file. So after you get the file is telling us, you can see this file is telling us that we have 3,571 rows and 10 columns. These are the columns. The columns are employee ID, satisfaction level, last evaluation, numbers of projects, average monthly income, monthly hours, time spent in the company, and so many things. Okay, it's just 10. It's just 10. You can get the whole 10 when we scroll here. Work accident, it means if the person has had an accident before. Promotion for the last 5 years, the department the person belongs to, and then salary. So after you are getting this data now, that is when you can now begin to do so many things about it. Like, for example, we want to know the number of people that we want to know the distribution of this data by department. How many people are in sales department? How many people are in what is this? Support department? How many people are in whatsoever department that is there? Then we want to talk about the salary. Okay, this is the salary. We want to talk about those, how many people have the low salary, how many people has a medium salary, how many people has this and that. Those are things we can do on this. So far so good. We know how to import Excel file, and at the same time we can import a CSV file. So since I've done the work before, let me just take you through what I've done before. Now, this is the same file. This is the same file. Now, in this file, I've been able to work it out, like you can see, like in this case now, how many people, okay, work accident. When you talk about work accident, you can see I'm going to call on Matplotlib here. This is the work of the Matplotlib. It's going to tell me, plot some graph for me, like, okay, talking about the work accident. This is the limit of the people that has a work accident. So let's say they are just below 100. And like many people did not have work accident, like promotion for the last 5 years. So like many people has not gotten promotion. This one denotes that people that gotten promotion for the last 5 years, and these people did not have promotion for the for last 5 years in the company. And talking about the time spent in the company, like on average, majority are between 3 years to 5 years. You can see many people have spent 4 years in the company, like over 140 people have spent more than 4 years. I've spent on average 4 years in the company, and less than 5 years, like about 120 something people have spent 5 years in the company, and we have 6 years. We have about 40 something. I don't know, is it 40? Yeah, 40 something. Maybe it's based on times 100, depending, because I don't know the scale anyway. So depending on the scale, you can see what this is only telling us is that you can see that the people that spent 4 years, they are more than every other people. Like those people that have just spent 2 years, 3 years, and etc. Those are the information you can get from your Matplotlib. The same way, this one, I think, this one, you can see the only difference between when you use Matplotlib and when you use Seaborn, in most cases, Seaborn is going to give you more fancy, you can see this one is more fancy compared to when you use Matplotlib. You can see this one is not as fancy as when you use you can see this. So now this is the Seaborn you are using to plot a multiple bar chart. So there are so many things I want to compare here, like the salary. Compare the salary of those people that are on the low salary, medium salary, and the high salary. So based on the time spent in the company. And this one is based on low salary, medium salary, and based on what? I don't know. Let me check. I don't know what I base this one on, except I check properly. So these are the things you can do when you are working with the file. And those are the things we are going to learn how to do when we go more maybe by in our next lab, if you know how to do most of these things. But before you can do these things we are talking about, all this plot and do so many things, there are things you are supposed to know. So one of the things you are supposed to know, you must be able to do what is called data wrangling. You clean the data. How do we clean the data? I am not sure if this data okay. Oh, it's not having problem. This data don't have any problem. Okay. So we can do exploratory data analysis on it. Some of the things we can call on this is info. We can call .ed, so many things like that. And that is going to be what will guide us towards doing our exploratory data analysis. Now, for example, if I'm back to the one we imported, which data did you think we should work with? Let's work with, just to summarize what I've been saying, let's work with this diabetics data. If I have the diabetics data and I want to work on it, one of the things I will first check is to check the info, or I can first check the ed. I can say diabetics.ed. So if I run, it's going to give me the head, that is the first 5. If I like, I can put 10 inside the head. If I put 10, it's going to tell me the first 10 rows. So these are the first 10 rows. You can just look at the first 10 rows and like, okay, these are the first 10 rows. Okay, these are the first 10 rows from the data. If I like, I need the last 10 rows. I can call on .tail. I can say diabetic data .tail. If I just put .tail like this, it's only going to give me the first 5. You can see those are the last 5 of the data. Okay, these are the last 5. If I need it up to 10, the last 10, you just put 10 inside it and you run it. Then this will be telling you, okay, these are the last 10 data that you have. So you can check it. Okay, these are the last 10. Then you can call on .info. Whatever you have .info, the data.info, it's going to tell you the information about the data. Let's get the whole information. These are the whole information about the data. It's telling us that we have the columns. I hope you can see this. Hello, everyone. Hello.
Yes, you can see it.
Yes.
Yeah. It's telling us that we have 8 columns in the data. We have pregnancy in the data, we have glucose, we have blood pressure, we have skin thickness, we have insulin level, we have BMI, we have diabetic pedigree function, we have age, and we have the outcome. The outcome, like the person has a diabetes, it has no diabetics. And in most cases, it may be denoted by 0 and 1. You can see 0 means this person has no diabetes. This one has diabetes. This one don't have. This one has. This one no diabetes, no diabetes, no diabetes, no diabetes. This person has a diabetics. So it's telling us that this is the outcome. So you can actually check the age. This is the age. This is the diabetic pedigree functions. You may not really understand if you are not in H-line. So this is body mass index. So body mass index, and you may not really understand what body mass index is. So body mass index is just like how heavy you are. Let me just put it that way. Yeah. So there is a way to calculate your body mass index if you want to calculate. The insulin, you may not understand what insulin really means. But when you go to the hospital for checkup, they can check your insulin level and things like that. So your blood pressure, I believe everybody understands what blood pressure means. So this is at the of course, depending on diastolic or systolic level. So these are the measure, the glucose level and pregnancy. It means this data, I think, is only meant for female. So if you are talking about pregnancy, I'm sure you are not talking about male here. So this data should be female specific. When you are talking about pregnancy, this person has had pregnancy once, this one 6 times, this one 10 times, this one just twice, this one 5 times. So these are the pregnancy level if they have ever had pregnancy before. So now, what the importance of this is that it's like, we are talking about different type of data type. and we talked about numerical data type of the type float and the type int. If you see int 64, sometimes it can be int 32, depending on the type of system you are using. So if you see int 64, you are still talking about integer. This is an integer, this is an integer, this is an integer. Now it's telling us that this is float. And if you actually go and check, it's going to be float. Like this is going to be float, this is going to be float. So you check. And sometimes if any one of them has been denoted wrongly, you can change it. That is the first thing. Those are the first thing you must check. Okay, somebody put a pregnancy and now put maybe the data here, what you have here was float. Then there is no pregnancy of float. Maybe pregnancy or no pregnancy. Is either pregnancy or no pregnancy. And here, I might even decided to say this integer is wrong. Because the int should, if you are telling me about pregnancy should not be integer. If I want to work on this data, I will change this pregnancy, I will change it to Boolean. Please, did you understand what Boolean means? Hello?
True or false?
Yes, true or false.
Yes.
If you are saying, I think that is more appropriate compared to saying integer. What about, okay, no, since the pregnancy they are calculating here is the number of pregnancies, that is not true or false. Somebody that the number of pregnancies now, like 5, 6, 7, okay, is correct. But if you talk about this outcome, yes, this outcome, if I want to work on this, I will change this to Boolean. I hope you get this now. Because an outcome is get it as maybe the person has a diabetic or not have a diabetic. So it should be true or false, yes or no. So I will not be very okay to work with this. What about if somebody just intentionally, okay, since I put integer and somebody, it has been 0, 1, 0, 1, and somebody just intentionally to say, okay, I want to put 5. I want to put 3. I want to put 8. I want to put 10. That is going to be wrong. So I should be able to set this to be a Boolean because it's an outcome. Of course, if I see age, somebody is putting age and is putting it as float, I say, no, I'm not telling you, I'm not asking if you are 3 years, 5 months. No, I don't want it as float. I want it as integer. Don't tell me 3.5 years. If you want to tell me 3.5 years, then automatically, if this is to be telling us in something like years and months, then you might set this one to float. But I don't want that. I want it as integer. Body mass index should be a float because you can have someone with body mass index of 22.5, 23.5, 30.5, 30.3. So it can be a float, and diabetes pedigree function can also be a float. There is a way they calculate that. So you may not really know what all this thing means if that is not your field. So now we are saying before you start working, you don't just get the data from here. I already imported the data and fine, this is my data, and I start plotting the graph. I can just start doing so many things. No, the first thing you do data wrangling on it. Sometimes you can even have what is called a null. Now, in this one, you can see we have 768, 768. You can see everything is 768, which shows that there is no missing data. If I'm able to get any data that have a missing data, let me check my system. You will see that you will see that it's going to be saying there is a missing data. And if you have a missing data, there are things you can do on it. Some of the things you can do on a missing data is to input or maybe to remove the data from your whatsoever working you are doing. Let me check. Let me check if I can get some data that we have. Okay, I got one. Yeah, I've seen one on my system. So let's quickly import another one. I'm sure we are all comfortable importing data now. So if I want to import, of course, you know where I will go. The first thing I will do is to come to this side. When I click, it's going to bring, when I click this, it's going to bring this out for me. I will now go to where I want to get the data, so and import it. I have my desktop. I have a data on my desktop. on I think I have the data on one campus. Yes. I have a data of heart disease. Let me import the two because I don't know the one that will be good. I have two data here. So two data have been imported, but the two data, they are CSV files. So let me import this is one. Let me import B and C. Let me import this one. Let me call it as, let me call it add PD df data frame is equals to PD dot read. Now what I'm reading CSV. So what's the name of the CSV I'm reading? I can just type it directly. Let me put it, since it's a string. And mind you, if your spelling is not correct, you are never going to be able to, it's not correct the way it is spelled. .csv. So if I run this now, I should be able to get the data. Oh, there is a problem again. Let me just copy.
Underscore.
Let me just, what did you say?
It's underscore just before B instead of that.
Okay, thank you. Underscore. Yeah, thank you. You can see, if you make mistake, you will never be able to get it. So now we got that. Let me print it. Let me run it. This is the data set I have here. Now, in this data set, yes, you can see in the data set, you can see NaN is a non-value. Maybe when they were filling the questionnaire or whatever the method that have been used. In this data set, I have 1,500, 1, 2, 3, 4, 5. Okay, 1,500 and 158,701. Yes, 158,701 row and then 18 columns in this heart disease data set. So you can see the columns we have. These are the columns. These are the columns we have. The heart disease. This heart disease, if I like, I can call it Boolean, yes or no. You understand? So body mass index, smoking, alcohol, drinking, stroke, physical health, mental health, etc. Those are things you have under that. You can check everything. Now, the first thing you can do is to first say your heart disease.ed to see the first 10 columns if you want, first row rather. So by the time you click it, you are going to get the first 10 rows. So these are the first 10 rows of this data. If that is what interests you, those are the first 10 rows. From the first 10 rows, you can have an idea of what is inside this data. So you have the first 10 rows. Then the next thing you can do is to do .describe or .info. Let's do .info first. .info. Info. So it was the info we were going through the other time. Now in this info, this is telling us that these are the columns. We have about 18 columns because we started from 0. You know, it ended at 17. We saw that we have 18 columns, right? Now, in these 18 columns, there are so many things we are going to have problem with here. We are going to change so many things. It's telling us that heart disease, this is an object, should not be object. Should either be true or false, which will be Boolean. So heart disease, you can see it's telling us yes or no. It can be 1 or 0, true or false. So when you say object are things like female, male, they are text. So you can call those one object. But why this one was denoted as object was because it was written as no, yes, no, yes. So that was why it was denoted as an object. But if I like now, I can go and change it to Boolean. Though object may still be good as yes and no. Now, body mass index is float, which is good. Smoking is object, yes. That one can also be Boolean, yes or no. Okay. Then alcohol is subject, of course. It can also be object, it can be Boolean. Do you drink alcohol? Yes or no. That is what I want. Stroke. You have history of stroke? Yes or no. That may be what is expected here. That is why all these things, they are all object. And then this one is float. That is how you will check every column one after the other. Those that you think the data type, you see D type, it does not correspond to the column. You will later go and change them. Apart from that, there is a great deal of information that we have gotten from here. The total entry we have is 158,158,701. But if you see here, it's not everything that is 158,701. Some of them are less. This is 158,685. It means many people did not fill their body mass index. There are missing values. So compare it to the first one we had. You can see here everything from A to Z, 768, 768, 768. We saw that in this data there is no any missing value. Compared to this data we have here, we have missing values. So there are lots of things you are going to do once you have a missing value. Apart from calling .add, we have been able to call .l. We have been able to call add. We call tail. We understand what tail means. We understand what add means. We understand what info means. Info. We have dealt with info. There's another one we can call undescribed. We can call on .describe. Let me run. Let me run that. .describe. Describe. My describe was wrong. This is the describe. .describe. So when you call on .describe, you run it. It's going to tell you some statistics about. There are two data you will always have. There are two forms of data you will always have in your data set. Those that are continuous data and those that are numerical. Those that are continuous data are also numerical data, and those that are categorical data or non-numerical data. Like the Ax disease is a non-numerical column. This one is a numerical column. This is a non-numerical column. This is a non-numerical column. And when you call on .describe, the .describe will only talk about the numerical column. It's a form of statistic. And you know it's not going to be able to run statistics on the non-numerical column, telling us about the minimum you have in there, telling us about the other things. So .describe will not be able to do that. So except we specify some other parameters. So, but for now, see, these are the those are the ones that are continuous data, numerical data from our data set, the numerical columns. These are the columns for this, column for this, column for this. Those that are numerical will be summarized by .describe. So in .describe is a form of statistic. Like in this one now, we have the number of count for body mass in there is 158,685. And normally we are supposed to get 158,671, which shows that our body mass index is having some missing value if you check it, because it's not up to the total number we're looking for. It ended at if you check back when we first called the data, that is 158701. That is the total rows we have. But now, when you check the total rows that is under the body mass index, it's not up to that. It shows that the body mass index, you check the column for body mass index, there will be a non-value. There is a way we check for the non-value, which we will eventually get to. If you check under this one, it's not, that one too is not up to what we're looking for. So it means there is non-value here, the same thing here, there is non-value, and the same thing here, there is non-value. Every one of them has a non-value in them, those that were not inputted. And if you check back the data, you will even see from the last 5 that those non-value as they are there. See, the last 5 you can see. Under this one, there is a non-value. 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 And if you check in the middle as well, there will be a lot of non-value that we can see that are hidden here. So you can't see them. You can't see the old data. You can't see it, except you call on another function to see the old data, which you don't want to do. Because sometimes you will just be looking at it, there's nothing you can do with it. The best thing you can do is just to do all this statistical analysis to get what the data look like. So after getting that, this is telling us that the mean of this body mass index is 28.3. The standard deviation is 6.3. We are going to work on the statistic later. What all these things, how all these things affect our data. Then the minimum you get from the body mass index, it means the minimum body mass index in the data is 12. While the maximum, okay, the maximum body mass index, where is it? Okay, that is 98. This one may even be, this 98 body mass index, I don't see it coming. Someone having a body mass index of 98. This may even be an outlier. And from here, you will know if the 75% is 31.45, you can see that this may eventually be an outlier. If the mean, the middle body mass index is 27.32, then you don't expect the maximum to be more than like 50, because this is 27.32 times 2. That will give you what the maximum should look like. And you are now having a maximum of 94. Then this may be an outlier. There are so many things you are going to be able to deduce from here. And then it's telling us so many things about the 25%, the minimum, the same thing with all these. So these are things you can get from the data we imported. Now we are treating multiple data because I just want us to know what data look like in a Jupyter notebook, how you import it, how you install the libraries you need, how you import the libraries you need, how you bring your data into the Jupyter notebook, and after you bring the data into the Jupyter notebook, what can you do on them? Some of the things we can do on them is what we have discussed. You can call on dot describe, you can call on dot add, you can call on dot tail, you can call on what else again? You can call on dot info. And all these things you are calling on, they are going to be telling us of information and be giving us an idea of what we should do on the data. Or like this one that I already call on the dot info, and I'm getting something like this, showing me that my data has some missing value. So I'm already having some idea, like before I do anything, I should deal with this missing values. If I have missing values, I want a condition where everything will have the same entry, just like this one. I want a condition where I will have everything having 70, like this one has 768 throughout. So I need a condition where, like for this data, I will be able to have a condition that everything here will be the same thing. What can I do to achieve that? Sometimes I remove everything that has no value. Sometimes you don't have to remove it. Your data is not much. You cannot remove everything. You can input using an average. For example, I'm dealing with the data, and a data gives a particular entry where I have cells. The cells are the male and female. And by the time you check the cells and you discover that maybe 60% of the cells that were there, they were female, while the 40% were male. And there is the way I now have some other things that some other entry that has no choice, whether of male choice of male or female. You will just input using maximum. The one everybody has been female, so why not just assume that those people are female as well? So you can use the assumption by using the maximum number, which we call mode. Sometimes, if it is continuous, you can use main. Just use the main value. If it is continuous, this thing, just use the main. And there are some other cases, you just remove them if your data are merged. If I remove them, if I remove all this one, then those things are negligible. Let me just remove them. So you can remove, and there are ways to do that. So now, another thing you can do is to call for the statistic. The statistic, when you call on the statistic, you can actually see what the maximum look like. You compare the maximum with the center point. If this is the main, you can compare the maximum with the mean, if you like. So, or with the center point. So if this is 23 as the 25%, or 50%, we have 27 as the 50%. And when you take the mean, you have 28. You can see that the mean and 50%, they are somehow close. Then which shows that the maximum should not be more than times 2 of whatsoever you have as the mean, or times 2 of whatsoever you have as the 50%. So, but the maximum is now more than that, far more than that. You are going to reason that there are some outliers. The outliers, they are things like someone mistakenly, maybe I want to put my age. You are collecting data, and I fill all the other data and also fill the age. And instead of me to just put maybe I'm 25 years, I now mistakenly put 225. Of course, it's not possible. It's either I want to say 22 or I'm 25. There is no way I can say the age is 225. So when you check some data, you are going to see 225 as the maximum. Then you just reason like this is not possible. It's not possible there will be age of 225. There are outliers. So you can remove some outliers and okay, if any value that is more than this, please remove them from the data or adjust them. So those are outliers. Like this one, I'm very sure there is an outlier of 94.5 in a body mass index. I don't expect a body mass index to be up to 94.5. However, you must have an idea of what the data is talking about before you can begin to make some submission. Like if you go and bring data that have to do with finance for me, and I just come and say, okay, they are talking about the index. I don't know, in finance, they always talk about something index like that. And I just check it and I'm telling you that the index will not be like that. Then I should be wrong because I don't have an idea of what I'm talking about. So you must have an idea of the data. You must be an expert in that area before you can begin to remove and substitute. So you that don't really know what a body mass index means and you don't even know the range, you cannot be telling me that 94.85 is wrong or is going to be an outlier. But easy data that we can easily understand is like age. Everybody should understand that. If you are telling me the age is 225, I will say no, that 225 is an outlier. Remove it from the data or replace it with the mean. What is the mean of the data? Replace it with the mean of the data. Now, let's look into this physical health. The minimum of this physical health is, the mean is 3.3, the standard deviation is 7.9, the minimum is 0, it means it starts from 0, then the maximum is 30. So I don't know what the physical health, what they have used to measure the physical health. So, but if you check the 50%, the 50% is 0. So which shows that there is no possibility, there is no way if the 50%, even the 75% is 2. So you don't expect the maximum to be up to 30. So there is an outlier here. It means this physical health may run between 0 and 1. 0 and 1. Maybe the major thing, or maybe between 0 and 5. It cannot be up to 30 because even the 75% is 2. So if the 75% is 2, you don't expect 30 from such a stuff. So there may be an outlier. Let's talk about the sleeping time. Okay, the minimum sleeping time here for someone and for the old data is 1. Maybe in an hour, I don't know. Someone is saying I sleep just for an hour, and the 25% is 6. So, okay, I see 25% of them said they sleep for 6 hours, and 50% is 7 hours. Then 75% is 8 hours, which is good. But if you are telling me there will be a maximum of 24 hours, it's an outlier as well. Because fine, so there could be 24 hours is possible. But it is not possible for someone to just be sleeping every time for 24 hours. Maybe the person wants to put 4 hours and mistakenly, because you can see the 75% says 8 hours. So the highest will just be about 12 hours. maybe you sleep throughout the night, 12 hours. So it's not possible. You have someone saying, I want to sleep for 24 hours. So these are the beauty of calling all these statistical description on your data. So we have talked about the tail, the head, the info. Of course, you are going to get a lot from the info, and you are going to get a lot from the describe. Only that we have only been able to talk about the numerical. We are yet to talk about the categorical data. We have some set of categorical data, like all those that are that were referred to as objects. Objects here, all these object. The describe is not going to talk about them because they are not numbered. So it's only going to talk about those that are floats and ends. But when it says it's an object, the describe is not going to talk about that. There is a way we also take the statistical description of that. But before I continue, let me just stop here and expect a question. This is just this is not going into the detail per se. I'm just trying to familiarize us with what we are going to be coming across, what we are going to see, the beauty of where we are going. Because we have not even chosen any particular data now. We are just moving from one data to another, telling us that these are the possible things on how to import them. These are the way they are going to look like, and these are possible things we should do on them. And we have not started taking any data and working on using this expository data analysis or doing anything on them. We are only telling us where we are going, what we are likely to meet, and how we are likely to solve some of these problems. So let's quickly listen to the house and see if we have any questions for now. So please, everyone, the floor is yours.
Yes, I have a question.
Yeah, you're welcome.
Now, as it relates to Outlier, based on what you said, we can, you know, we can assume what the value is based on the other data that is there. But assuming doesn't mean it's correct. So wouldn't that mean that the data can be not accurate?
Yeah. The problem you have as a data science, as an analyst or a data scientist, is the quality of the data you get. You know, it is always difficult to get a quality data. Either intentionally, some people will just input some things there, or unintentional. It is difficult to always get accurate data. You cannot get 100% accurate data. It is now your job to check for the quality of the data. You check the data, you see how, of course, if it's as accurate, it can maybe be accurate to up to 90% is good. But for you to even get up to that 90% is going to be a lot of work. You are asking people to input all this data. Some people can even put some character. You want to put like say 25 and you put B2. Maybe on your system, maybe there is B on the 2 that you want to put, you will ask 25. Or maybe, okay, if I check my system now, I have $sign on my 4. Maybe I want to write 45 and I mistakenly press shift and I now press $sign and now put 5 at the back. Something that I wanted to put 45, I'm now putting $5. You can see it was not intentional, but because of the process of inputting all this stuff, there is always going to be a problem in the data. There is always going to be. You cannot get any data that is going to be 100% accurate. That is where you now step in as an analyst to look into this data and then make them to be at least to the minimum perfection that they can be. So that is going to be your work. You can never get data that is modern. And if you fail to do all this stuff, you are going to interpret, your interpretation is not going to be accurate. If you don't input, remove, you don't just input, Of course, I already said you must have the knowledge, the base knowledge of what you are inputting or what you are removing. You don't just remove. So you have to remove input where necessary to be able to give an accurate prediction. Because at the end, whatsoever you have worked on doesn't stop with you. It's going to be communicated to people that will make decisions on them. So now it's going to be wrong for you to be telling someone that in your data you have someone that is of age 150. Of course, there could be, but this age, they are going to be a very negligible people in the world that will be within the age of 150. So you should know that such data is going to be possibly going to be an outlier. Then you have to remove them. Hello, I'm with you.
Okay, thank you very much.
So please ask your question. Any other? Hello, everyone. So if there is no any other question, so I will say we may have to stop here. Of course, we said now we are always going to be working with time. All we have to be doing now is going to be very interesting compared to when we were in introduction to Python. The only thing I have to do now is to think of very dirty data. Look for a very dirty data against our next class. And I will come with a very dirty one and expect us to work on the dirty data. And at the same time, teach us some little statistic on what those statistics represent. So that is going to be how we're going to continue with our wrangling. So if you have anything to say, you can say it, but I think it's going to be a good place for us to stop for today and prepare against our next class. Blaise, I'm with you. Blaise? Hello, Blaise?
Yeah.
Are you there?
Hello. Oh,
Yeah.
Ian, you're muted. Sorry if you're talking.
Okay.
Oh my God, sorry.
Yeah.
I'm just saying, yeah, thank you, Abdul. Has anybody got any questions for Abdul before we wrap it up? Mary, Alphonse, Olusolu, Lawrence, Ricardo, Mercy. Is everything crystal clear? Or is there anything that you need to be clarified? Please, Abdul's more than happy to help you.
Okay, thank you so much for the class. How can I get the recorded version and the files that we used?
Yeah, so if anybody visits the BDPN website, let me share my screen real quick. So from the BDPN website, it's probably going to be very slow because I'm on Zoom getting onto the page, so bear with me. Right, here we go. So the Content Hub, which is here, Content Hub, if you click on there, and then from here, all the previous sessions from Abdul are here. Okay, so today's session will be loaded Monday, Tuesday at the latest, something like that. So last weekend sessions here and so forth. Okay, there's also loads of other content on here, loads of videos from Black data professionals talking about their career journeys, how they got into data, why they made certain decisions. So we've got some real good influential individuals sharing valuable insights with you. So there's a lot of content on the website. But yeah, so again, the Content Hub, the mentorship program, we've got vacancies on there, jobs on there as well. But the Content Hub is where you'll get the previous recordings from Abdul.
Okay, thank you so much.
So I'm talking about the data you are to use. I already shared them in the chat. So maybe I can also share them on the WhatsApp if you are not able to download them from the chat.
Yeah, ideally we need them before. We need the slides and the data sets for each session beforehand. They can be better prepared and we can share them with each other. We're working towards doing that. We understand the value. I get messaged every day from people saying, look, you know, so I'm going to be speaking, we're going to try and arrange that for you all. Mercy, have you got a question?
Yes, I have a request. I don't know if Abdul could remember when we are opening the Google Colab page, there was another link he sent to us to make a download. I can't really remember. I've lost that. I don't know if that could be added to probably our next class chat box or the WhatsApp page or somewhere we can easily access it. Or is there a place I can get it?
I can't really get the link you're talking about. Maybe is it VS Code?
Yes, I think so. Yes.
VS Code. Normally, you can just even go on your browser, type VS Code installation. It's going to give you the installation path. So you just download from there and install. The one that is specific for your system. It's easier.
Okay, please, can you just type it on the chat box so I could just copy it?
VS Code.
Yeah, thank you.
Okay, you're welcome.
Just to say, we've got the WhatsApp group available, and if you've not joined, I'll just put the link in the chat. Please join the WhatsApp group. All slides,
yeah,
resources, and
group.
links and everything will be posted in the WhatsApp group. So I'll just quickly put the link for the WhatsApp group right here now. And then also we usually send out emails as well. So keep your eyes on your emails. You see all necessary links and resources and everything, and then as well as the WhatsApp group.
Got a huge wasp in here.
So slides and every other information will be shared in the group chat, the WhatsApp group. So
and on email as well.
And on email as well. I've shared the link if you've not joined.
Okay.
Just joined, and yeah.
Alex, Ricardo, Olusolu, any questions? Alphonse? Anything you're not clear about from earlier today?
No, no questions from me.
All right.
Thank you, Ricardo. Cool.
Okay, so
everyone's all good. Everyone wants to get out and enjoy the sunshine. We've got sunshine over here in the UK, so which is a rarity. It doesn't happen very often. So everybody wants to get out there and get some sun rays. So yeah, if anyone hasn't got any questions, we will leave it here. And there may be a recap session on Friday, but we will let you know during the week if there is a recap session. If not, it will be business as usual, Saturday morning, 10 o'clock. Is that all right, guys? Yeah.
Sure.
Yeah, that sounds good.
Yeah, please note that the Friday session is not only for recap as well. I'm sorry to say this, and we could as well pick up from where we ended. You know, if we're running behind on a particular session's lecture or material, so let's just have that in mind. Fridays as well. If you are available, please do join the session. It's always recorded, and then also, but for your understanding, and yeah, it's good to join if you're free.